Hi students, it's Mrs. Gifford. Today we're going to do section 7.3 about similar triangles. And after today's lesson, you're going to be able to identify similar triangles and use them to solve problems. So let's take a look here at some postulates and theorems. The first one is angle-angle similarity. AA, angle-angle similarity. And if two angles of one triangle are congruent to another, then we can say those triangles are similar. Side, side, side. If corresponding lengths of two triangles are proportional, then we know they're similar. Side, angle, side. If two sides of one triangle are proportional to two sides of another triangle, and one of those angles is congruent, then we can say they're similar. So take a couple minutes and write. Hit pause and then write this information down. Okay, now we're back. So we've got some more postulates and theorems to look at. Theorem 7.4 just shows different properties of similarity: reflexive, symmetric, and transitive. And then this bottom one, I thought is a nice way to kind of summarize everything that we had talked about on the previous slide. So let's take a look at some examples. This first one, we want to determine whether the triangles are similar, and if so, we're just going to explain why. So we've got triangle ABC and triangle DEF, and we see that in triangle ABC, we know that it has a right angle, so we know it has a 90-degree angle and a 47-degree angle. So if we want to figure out the measurement of angle A, what can we do? Well, we know that triangles add up to 180 degrees, and I know that 90 plus 44 is 134. So I can subtract that 134 from 180, and I get that angle A is 46 degrees. Okay, and then we can do the same thing for this other triangle. I've got this right angle, so 90 plus 47 is 137. And to find angle G, we can take that 137 away from 180. And we end up getting 43 degrees. And did we get the same angle measurement? No, we didn't. And we can say that they are not similar because...
Crowd, if you're in a building, please come to the main office. The student crowd, come to the main office.
Sorry about that. Because we don't have two pairs of congruent angles. Okay? So that's the first example. So now let's take a look at example 2, and we're going to do the same thing. We have to determine if these two triangles are similar, just like the one before, and if they are, then we're going to write a similarity statement. So I see here that angle W touches for both of them, so we know that angle W is congruent to angle W because they share. And we also know that TW corresponds with YW, and so if we look at our information, we can gather that 10 over 20 is equal to 1/2. And then we have ZW corresponds with XW, and that's 11 over 22, which also simplifies to 1/2. And so what do we see here? We see that we have two sides that are in proportion, and then we also have an angle. So we can say by side, angle, side, the triangles are similar. Okay, on to our last example. In this case, we don't have to figure out if they're similar. We just have to find the measure of the length of side WR and the length of side RT. So if you look closely, we see that each part has an X, so we're going to have to find the value of X and then put that into each of those expressions to actually figure out those side lengths. So we say that SW corresponds to VT and WR corresponds to TR. So the information we get there is we can write the proportion of 8/10 is equal to x plus 6 over 2x plus 6. And from here, again, we can do that because we are given that they have this angle that's congruent, and then angle R is the same between each of them as well. So from here, we can do what we talked about earlier, and we can do cross products. So I've got 10 times the quantity of x plus 6 is going to be equal to 8 times the quantity of 2x plus 6. And from here, we're going to use algebra to find the value of x. So like we did the other day, we're going to distribute the 10 and distribute the 8. And now we're going to solve for x. So I'm going to subtract 10x from both sides. And then subtract 48 from both sides to give me that 12 is equal to 6x, and dividing by 6, I get x is equal to 2. We're not quite done. That's not our solution. Remember the question said what's the length of those sides, so now we're just going to take that 2 and substitute it into each of those expressions. So for WR, we've got x plus 6, so it has a length of 8, and then RT is 2x plus 6. So again, substitute that 2 in for the x, and we get a length of 10. So here, 8 and 10, here are our solutions. So that's it, folks. Writing proportions and using information from similar triangles to find missing lengths.